For the third video here on normal distribution, we're now looking at something called inverse normal distribution. And that simply means we're kind of going the other way with the math. And so up to this point, all the information that they had given you was relating to some point within your drawing. And this graph didn't come out, so I'm going to show it to you here in a minute. I drew it out separately. But in every case, they were asking you for a percent. So they would give you some number along the x-axis, and they would say something like, you know, what percent is greater than 990, or what percent is between 980 and 1,000. Or they would give you those numbers, and they're asking you for a percent. Well, inverse normal does the opposite. They give you the percent, and they ask you for the x value, one of these guys, that would go with it. And so that's going to be the difference between the two. We're still going to do this on the calculator though, so have your calculator handy as we go through this problem. So right here I want to show you, it says it's known that 10% of the cartons have a volume of less than X. And so again, we don't know where the X value is. All we simply know is that there is 10% to the left of it. So that's going to place X somewhere in this neighborhood. We just don't know exactly where that would fall, but that's what we're trying to find is the X value. So with the basic drawing, you got the 995, you got the 5 milliliters. So let me just show you really quick by hand how that drawing should have come out, which theirs didn't real well. But so here's the drawing. So they gave us a mean of 995, and if we branched out with standard deviations, it would look something like this. Again, they said something that there is 10% less than X, and so remember what these guys represented. This was 0.5%. This was 2%, and then this kind of went bigger to 13.5. So 10% to the left would put me somewhere in this neighborhood. So this is the value that we're trying to find. And again, all they told us is that there was 10% to the left of X. So they're referring to this shaded area right here that represents 10%. And we're trying to figure out the X value that would make sense. So it's going to go somewhere in here. I know it's between 985 and 990. We just don't know exactly what that is. So that's what we're trying to come up with for this problem. So if you go back to your calculator, we're going under the same distribution area that we were for normal distribution. This is just inverse is one number down. So when we did the normal CDF, that was option 2. Inverse normal is going to be option 3. And so select that button. Instead of 4 prompts, there are now only 3 prompts. And so the first one that you're going to have to answer is the percent question. So they want to know what is the percent left of X. And so in this case, it said that there was 10% less than X. So we're putting in the 10%. Notice it's going in as a decimal, so we don't put in 10, we put in 0.1. So that 0.1 represents 10%. And then again, you're going to put in the mean and the standard deviation as the last two. That was the same as normal distribution. It's just the first part of the prompt that's different. But anyway, so right here, so about 989 is what we would round that off to. So let me take you back to my drawing really quick. So 989. So, and again, remember what I said, I knew it was between 985 and 990. I just didn't know exactly where, but they said it was 989. And so that does make sense with the approximate drawing that I have would represent that 10%. Okay, so here's a huge key when it comes to inverse normal. When you answer the first prompt and you put in a percent that they're asking you for on that first prompt, your calculator always wants to know what is the percent to the left of X. So that's why we put in this 10%, because it's 10% left of X. If there is 10% to the left of X, well, that must mean that there's 90% to the right of X. And so keep that in mind for a minute. So this way there was 10%. This way that means there is 90%, which means they could have worded this exact same question by saying that there is 90% more than X. And we actually would have come out with the exact same answer, because whether we say there's 90% to the right or 10% to the left, we're still referring to the same x value. And so if they were to word this by giving you something to the right, you still have to put in this number. So we would subtract this from 100 and get this number to go into the calculator. This is always the number that your calculator wants to know, is the percent that is to the left of x. And so keep that in mind. That's really important. So just in case you missed that on your calculator, again, right here under distribution, so second distribution, go down to the third option, which is inverse normal. So the first prompt, they're asking us for an area. And again, that is the area that I shaded here. It's the area that is to the left of x, never to the right of x. So that area represented 10% of the diagram. So 0.1. And then we put in the mean, which was 995. And the standard deviation, which was 5. And so there we go. There was about 989. So moving on here, example 5. So example 5 is like the perfect question because it contains everything you need to know about normal distribution all rolled into one question. So this is what we started out with in the earlier lessons of normal distribution. We have an inverse normal question here. We also have an expected number question. So this is kind of like everything you need to know in a nutshell right here for example 5. So pay close attention to this one. So it says the weight of pairs are normally distributed with a mean of 110, standard deviation of 8. And so one thing again that you need to know how to do with this is to make a proper drawing. And so with a mean of 110 and a standard deviation of 8, one of the first things you got to be is just how to draw a proper sketch. These are, you can be asked for sketches within a test, and so it's important that you know how to draw them. So again, just a proper sketch for normal distribution. So we're going to create that bell curve. So something like this. So we're creating that bell curve. So we know that 110 goes in the middle. That was the mean. So I'd put my 110. They said the standard deviation was 8, and so I would be adding 8 to the right, subtracting 8 to the left. And again, you would do that for 3 standard deviations. So I got to fill in 2 more to the right, and you would have to fill in 2 more to the left. And so you would have those 7 numbers. And again, so that would answer the question that just says, give a sketch of this scenario. And that this would be our sketch. And so we label those numbers, we draw the bell curve, and that would be the first part of this. So there's the sketch that you're seeing over there to the right. Now we can go ahead and answer a few questions. So first part, find the percent of pairs that weigh between 1 and 130. Again, recognize the question. This is a percent question, so right off the bat we know it's normal distribution. If you compare that to this one where they give you the percent and they are asking you for a specific value, that's the inverse normal question. So that's the difference between those two. So we got a basic normal distribution percent question that are between 100 and 130. Again, those are not standard deviations that we have labeled within our drawing. So 100 would be somewhere in here, 130 would be somewhere over here, but we didn't land on those numbers, so I have to use the calculator for this. But again, if we go to the calculator, again, you go to the normal CDF feature and then answer the prompts. So because this one says between 100 and 130, that makes 100 your lower bound, 130 your upper bound. And then if you put in the mean and the standard deviation, and as always, do this to 3 sig figs. So 88.8%, which again, you could just write as 0.888 and leave it at that, or do it as a percent. But always go 3 sig figs to be safe, unless the directions say otherwise. So that was part A. Part B, again, you would need to recognize, hey, they're giving me a percent, and they're asking me for a specific value, so I know this is an inverse normal question. There will be a question, especially for those of you who take the IB test, this is something you should know how to do, where they ask you to sketch something for part B. And so here's how a sketch would look for part B. If we know that there is 8% more than X or more than M or whatever letter they want to list. So if we know that there's 8% more than M, here is what a sketch for that would look like. So for this one, all we know is that there is 8% more than M. So a real simple sketch for this would do something like this. If there's only 8% to the right, that means M is pretty far to the right. So M is somewhere over here, and I know there is 8% to the right of that. So that's it. This is the sketch that they would ask you for an inverse normal question. Appropriately place the variable, and then place the percent that they're referred to within the problem. So that's how your sketch would look like for an inverse normal sketch. Here's why that sketch can really help you out. Something I mentioned earlier, that when you do inverse normal, the first prompt that they ask you for is an area. Well, I know this area is 8%, which means if there is 8% to the right, what percent is to the left? So if I do 1 minus 0.08, that means 92% is to the right. That's really important because when you answer the area question within your calculator always wants to know what is to the left of your variable, never to the right. So it's the 0.92 that we have to put in there for the area within our calculator. So don't miss that. That costs people a lot of points on the test. So here's the key statement that they're talking about within the PowerPoint right here. So if there's 8% to the right, that must mean the other 92 is to the left. And so we got to use the 0.92 for the area prompt. And so those are the answers to the 3 prompts that you would have. And if you just hit enter on that a couple times, you can see that M would be about 121. Notice that's not a percent. That's an x-axis value, right? It's a weight. M was somewhere over here, so it's a weight. A lot of times people will put this as like 121%, but that wouldn't make sense, right? We're not talking about an area here. We're talking about a specific x value. And so that's the inverse normal question. Here's the last one. Part C, 250 pairs are weighed. So now they're giving us a specific amount that was surveyed, and they want the expected number. So the expected number less than 105. So again, we're going to do the normal distribution feature. So if it's less than 105, right, that means to the left we are headed towards negative infinity. The upper bound is 105, the mean and the standard deviation. This gives you the percent. Do not round that off. Keep that exact number and just multiply it times the 250 that were tested to get your amount of pairs that they'll be referring to here. So it's, again, this is somewhere between 66 and 67. To play it safe, always do 3 sig figs unless the directions say otherwise. If they say to round it off to the nearest pair, then round it to the nearest pair. But if they don't say something like that, then just do to 3 sig figs and you'll be safe.